Welcome to Talk Tensors. We uncover the most exciting developments in machine learning research. Today we're going to take a deep dive into advancing semantic future prediction through multimodal visual sequence transformers. This paper has been making some serious waves.
It's a really cool paper. They introduced this new method, they call it Futurist. And it's all about predicting the future, but not just as, like a sequence of images. It's about understanding the objects in a scene, like how they're moving and all that.
That sounds seriously complex.
Yeah.
What makes this research so important? Like, why should our listeners even care about predicting the future, with AI?
Okay, so imagine like self-driving cars, right? But they can actually anticipate what a pedestrian's going to do. Like if they're about to step into the road, the car knows even before it happens. Or think about robots in a factory. They could work seamlessly with human workers, predicting their movements and, just avoiding any collisions. That's the kind of potential we're talking about here. It's about AI systems that get the world around them and can make these informed predictions about what's coming next.
Okay, that makes sense. But haven't researchers been trying to predict the future with AI, forever? What makes Futurist different, better than those other approaches?
You're totally right. Predicting the future has been a big goal in AI for a long time, but those older methods, they mostly focus on predicting raw pixel values, which takes a ton of computing power, and it doesn't really capture what's actually happening in a scene, like the meaning of it all.
So instead of predicting every single pixel, Futurist is more about understanding the scene, right? Like the semantics of it. What does that even mean?
Exactly. It's like this, instead of just seeing a bunch of random pixels, Futurist sees a car moving towards a pedestrian on a street. It gets the scene in terms of objects and how they relate to each other. That's way more helpful for making predictions.
So it's kind of like teaching AI to see the world the way we do, recognizing objects and understanding what they're doing.
That's a perfect way to put it. And that's where Futurist gets really innovative. They use this special type of neural network, a transformer, which has been blowing everyone's mind in natural language processing. Now they're using it for video understanding and future prediction, and the results are, amazing.
We hear transformers everywhere these days. Could you, remind our listeners how they work and what makes them so special?
Okay, think about reading a sentence. You don't just look at each word separately, right? You think about how they all fit together to make meaning. Transformers do something similar. They can analyze relationships between different parts of a video, so they capture both the spatial and temporal dependencies, how things are related in space and time.
So it's like the Transformers watching a movie, and it's paying attention to how all the characters and objects interact with each other.
That's a great analogy. And being able to understand those relationships is key for predicting the future. I mean, the future isn't just some random stuff happening, right? It's a result of actions and interactions that happened before.
Right, okay, I get that. So how does Futurist actually use this transformer tech to predict the future? Does it just watch a bunch of videos and try to guess what happens next?
It's a bit more complicated than that. Futurist takes in a sequence of frames, but it's not just looking at the raw images, It's actually processing multiple types of data at the same time, like object segmentation masks and depth maps.
So it's getting a much richer understanding of the scene by combining different sources of information, kind of like how we use our eyes and ears together to understand the world around us.
Exactly. And this multimodal approach, that's another big innovation with Futurist. By combining segmentation and depth info, the model can make more accurate and robust predictions about what's going to happen.
Interesting. So it's using multiple senses, you could say, to get a more complete picture. But how does it actually learn to predict the future from all this data?
Well, they came up with some pretty clever techniques to train Futurist. One of them is called multimodal masking, where they basically hide parts of the input data and make the model predict what's missing.
So it's kind of like playing hide and seek with the AI, making it fill in the blanks and learn from its mistakes.
You got it. And this masking is super effective because it forces the model to understand how different modalities are connected. Let's say the depth information for a certain object is masked out. The model has to use its knowledge of object segmentation and motion to figure out what the missing depth values should be.
That's wild. So it's not just memorizing patterns, it's actually learning to reason and make inferences about the world.
Exactly. And this leads to something they call synergistic learning. By combining those modalities and making the model fill in the gaps, they've built a system where the different data sources reinforce each other, and that leads to more accurate and robust predictions.
It sounds like they've figured out how to create a genuinely intelligent AI system, one that can perceive the world but also understand it and predict what's going to happen next.
It's definitely a huge step forward, and the results are super impressive. They tested Futurist on the Cityscapes dataset, which is full of real-world driving scenes. And it totally crushed it, like way better than previous methods.
That's a massive win. But before we dive into those results and what this all means, I think it's helpful to understand how we got here. Like, what led up to this breakthrough? What were the problems with those older approaches that Futurist was able to solve?
You're absolutely right. It's important to see like the whole history of this, Those early attempts at future prediction, they used much simpler models, and those models, they just couldn't really handle the complexity of real-world scenes.
So they couldn't actually predict the future with any real accuracy. Like, what were the biggest challenges they ran into?
Well, one big problem was just the sheer amount of data involved in video processing. Imagine, like, you're trying to predict every single pixel in a video frame, and you're doing that for multiple frames into the future. It's crazy. And early models, they just didn't have the power to do that effectively.
So it was like trying to solve this giant jigsaw puzzle with, like, billions of pieces. No wonder they couldn't handle it. Was it just about computing power, or are there other limitations too?
Oh, yeah, there was another big issue. They didn't really have semantic understanding. Those early models, they might have been able to generate future frames that looked kind of okay, but they didn't really get what was going on in the scene. They couldn't tell the difference between a car and a pedestrian, or like predict how they might interact.
So they were just mimicking what they saw without actually understanding it.
Exactly. And because of that, their predictions were often totally unreliable, sometimes even nonsensical. Think about it. Would you trust a self-driving car that couldn't tell a stop sign from a person?
That's a scary thought. So how did researchers start tackling those problems? What were some of the big milestones that led to Futurist?
Well, a big step forward was the development of recurrent neural networks, RNNs for short. They were designed to handle sequential data, like videos. They kind of had a memory, so they could learn from what happened in the past and use that to make predictions about the future.
So they were able to remember what they'd seen before and use that to make better guesses.
Exactly. That was a major improvement. But RNNs still had their limitations. They were tough to train, especially on really long sequences. And sometimes they had trouble, keeping their predictions consistent over time.
So they were a step in the right direction, but not quite there yet. What came after that?
Then came the rise of generative adversarial networks, GANs, and variational autoencoders, VAEs. These models were amazing. They could generate these super realistic images and videos. They really pushed the boundaries of what AI could do visually.
Wow, that sounds impressive. Did they solve the problem of future prediction, though?
GANs and VAEs, they were incredible at creating visual content, but they still had some issues when it came to future prediction, especially with tasks that needed a deep understanding of, like, the meaning of the scene, the semantic structure. They might be able to make a future frame that looked real, but it wouldn't necessarily make sense logically.
So they were great at appearances, but not so good at understanding meaning.
Exactly. And that's where transformers came in. They were like this huge paradigm shift in AI. Their ability to model those long-range dependencies and handle tons of data made them perfect for video understanding and future prediction.
So transformers could handle both, right? The visual details and the meaning of the scene.
Exactly. And Futurist takes that even further by focusing specifically on multimodal semantic future prediction.
Right. We talked about that before. It's not just about the raw images. It's combining all those different types of data like segmentation and depth to get a richer understanding.
Exactly. That multimodal approach, combined with the power of transformers, lets Futurist make much more accurate and robust predictions. Way better than those older methods that just used one type of data or less sophisticated models.
So it's like the culmination of years of research, right? Bringing together all the best techniques for processing data, understanding meaning, and predicting the future.
You got it. It's a testament to how far AI has come, and it opens up all these exciting possibilities for how we can use AI to understand and interact with the world.
Okay, so that makes sense. Now let's get into the nitty-gritty of how Futurist actually works. We know it uses a transformer, but how is it specifically designed for, multimodal semantic future prediction? Can we get a little peek under the hood?
Absolutely. Let's start by looking at how Futurist handles all the different types of data it receives. Remember, it's not just about those raw images. It's also getting info about object segmentation and depth.
Right, so it's getting a multi-sensory view of the world. How does it put all that information together?
It starts with separate encoders for each modality. Those encoders are like Specialized neural networks. They're designed to pull out the most important features from each type of data.
So it's like having different teams of experts, each one analyzing a different part of the problem.
Great analogy. Each encoder focuses on its own modality, whether it's identifying objects in the segmentation masks or like analyzing the spatial relationships in those depth maps.
And what happens once those encoders have done their thing? How does Futurist combine all those insights from the different modalities?
That's where the transformer really shines. The outputs from those encoders, they get combined and then fed into this multi-layer transformer network. That network is the heart of Futurist, where it learns to understand how those different modalities are connected and make predictions about the future.
So it's like the transformer is conducting an orchestra, bringing all the different instruments together to create this like symphony of information.
That's beautiful. The transformer, it analyzes the patterns and connections between the different modalities. It's learning how they all interact with each other over time.
Okay, but how does it actually predict the future? Is it just looking for patterns and then like extending them forward?
It's a bit more sophisticated than that. The transformer uses something called self-attention to analyze the relationships between different parts of the input data. It can focus on specific objects, actions, or spatial relationships, figuring out which elements are most important for predicting what will happen next.
So it's not just blindly following patterns, it's actually thinking about the scene and making decisions about what's most likely to occur.
Exactly. And that ability to reason and, prioritize information, that's what makes transformers so different from those older models. They're not just statistical machines anymore. They're starting to show a kind of artificial intelligence that can understand and predict the world in a more human-like way.
That's amazing. But we've been talking a lot about these high-level ideas. Can we get a bit more specific about how this self-attention actually works? Like what's going on inside the transformer that lets it make these smart predictions?
Sure. Think of the transformer as like a detective at a crime scene. They don't just randomly look at every piece of evidence, right? They focus their attention on the most important clues. Self-attention lets the transformer do something similar.
So it's like the transformer is shining a spotlight on the most crucial parts of the scene and ignoring the irrelevant details.
You got it. For example, if it's trying to predict where a car is going to go, it might pay really close attention to the car's current speed and direction, and also the positions of other objects in its path.
And it learns to do this all on its own, just from being trained on a bunch of videos.
Exactly. That's the power of deep learning. We don't have to program those rules ourselves. The transformer figures it out by itself. It analyzes huge amounts of data and learns which patterns are best at predicting what's going to happen.
That's mind-blowing. So it's not just following instructions, it's actually discovering its own understanding of the world.
That's the core of machine learning. We give it the data and the learning algorithm, but the model figures out the rules and relationships all on its own.
Okay, now I'm really starting to see how powerful this approach is. But there's one more thing I'm curious about. Earlier, we mentioned that multimodal masking technique, where they hide parts of the input data during training. Why is that so important, and how does it help Futurists do so well?
Right, yeah, that multimodal masking thing. It seems like it plays a big part in how Futurist learns. Like, it's almost like giving it a puzzle, but with some pieces missing, and then seeing if it can figure out the whole picture.
Exactly. That's a really good way to think about it. By hiding some of that input data, randomly, whether it's the segmentation mask or the depth map or even both, it forces the model to use what it knows about how those different types of data relate to each other to fill in those gaps. So like if the depth info for an object is missing, the model has to use what it knows about the object's shape and color and how it's moving, all that stuff it gets from the segmentation mask and the video frames to predict the depth.
Exactly. And that whole process, like making those inferences and predictions, it really strengthens the model's understanding of how those different modalities all fit together, which leads to better, more accurate predictions in the end.
It's like cross-training for the AI, right? Making it think in different ways and build a better understanding of the world.
That's a great way to put it. The researchers actually found that this multimodal masking technique really boosted Futurists' performance, especially when it came to those long-term predictions.
Yeah, that makes sense. The further you try to predict into the future, the more uncertainty there is.
Yeah.
So having a model that can actually reason about those missing pieces and make educated guesses is super important.
Definitely. And that's one of the things that makes Futurists so cool. It's not just blindly extending patterns, it's actively reasoning about what's happening and making judgments about what's most likely to come next.
So it's not just predicting, it's actually thinking. Before we jump into our novel notions section where we get to, brainstorm a little and explore some ideas based on this research, I want to touch on one more thing. We've talked a lot about how Futurist works, all the tech stuff, but what about like the real world implications? How could this actually be used?
Oh, the possibilities are huge, especially when you think about autonomous systems. Imagine self-driving cars, but they can anticipate what pedestrians and other cars are going to do way more accurately. That would make our roads so much safer and more efficient.
Yeah, that's a great example. And it's not just cars, right? We could use this tech for robots in all kinds of environments, like factories or hospitals.
Totally. Robots with this kind of futurist-like ability could work side by side with humans much more smoothly. They could anticipate our actions and avoid any accidents or hazards. Or think about disaster relief. A robot could predict where a fire or flood is going to spread and help rescue workers stay safe.
It's pretty exciting to think about all the possibilities. It seems like this tech could totally change the way we interact with machines and the world around us.
It definitely has that potential. And as research in this area keeps advancing, who knows what other amazing applications we'll see in the coming years.
Well, I'm definitely excited to see what the future holds for multimodal semantic future prediction and how it's going to shape our world. But for now, let's shift gears and get a little speculative. You ready to explore some novel notions with me?
I'm always up for a good thought experiment. Let's see where our imaginations take us.
Okay, so we've been talking about predicting the future based on visual data, right? But what if we could bring in other senses? Like, what if we could build a model that could predict the future based on sound?
That's a really interesting idea. I mean, sound gives us so much information about what's going on around us. Imagine a system that could listen to a busy city street and not just hear the sounds, but understand them, like knowing the difference between cars honking and people talking and sirens.
And it wouldn't just identify those sounds, it would actually understand the patterns and predict what might happen next.
Exactly. So a model that's been trained on audio data could learn to anticipate things like a car slamming on its brakes, or someone yelling a warning, or an ambulance coming up fast.
Wow, that would be so useful for all sorts of things like security systems or assistive technologies for people who are deaf or hard of hearing.
Absolutely. Like a security system could use sound-based future prediction to pick up on any weird noises or patterns that might mean there's a break-in or something.
Or think about a smart hearing aid. It could analyze the sounds around you and anticipate any really loud or sudden noises and adjust its settings to protect your ears, but still let you hear important sounds.
Right. The possibilities are pretty amazing when we start to think about combining other senses with these future prediction models.
And it's not just sound, right? There's touch, smell, taste. Imagine a robot chef that can predict the perfect combination of flavors based on what ingredients you're using and how you're cooking them.
Haha, now you're making me hungry. Yeah, I think incorporating more senses could really take AI to a whole new level.
It's almost like we're on the verge of creating machines that can actually experience and understand the world the way we do.
It's definitely a fascinating idea and a bit mind-blowing too. As we keep pushing the limits of AI, it's so important that we think about both the amazing things it could do and the ethical questions it raises. Creating machines that are more and more like us comes with a lot of responsibility.
I totally agree. We have to make sure we're developing and using these technologies in a way that benefits everyone.
Couldn't have said it better myself. That's a conversation we need to keep having as AI continues to evolve.
Well, that's all the time we have for today's deep dive into Futurist and this whole world of multimodal semantic future prediction. We covered a lot, from the technical details to the potential real-world impact and even some ethical considerations.
It's been an amazing journey, and we hope you found it as interesting as we did. As always, we encourage you to check out the full paper, the link is in the show notes, and keep exploring this fascinating field.
Who knows what amazing discoveries are just around the corner. Until next time, keep those brains buzzing and stay curious, everyone.